So next is the block of elements in the periodic table. Basically, there are 4 blocks in the periodic table. We have the S block, we have the P block, we have the D block, we have the F block. So the S block elements are normally the group 1 element, and the group 2 elements in the periodic table. They are called the S block element, the group 1 and the group 2 element. Another name for the group 1 element is the alkali metal. Then another name for the group 2 element is alkaline earth metal. Then the P block elements, are from group 3, group 4, group 5, group 6, and the rest of them. These are the P block elements. So the next is the D block element. The D block element are also called the transition metals. Then the next one is the F block element. The F block element are called the inner transition metals. So the S block element, how do you know them? The S block element are those elements whose electronic configuration ends with a S orbital. So if you are writing electronic configuration and the last electron entered the S orbital and there is no electron again, once the last electron enters the S orbital and stop there, that means that element in question is a S block element. So example, now if I'm writing electronic configuration 1s, 2s, and the last electron is found in this 2s, there's no electron again, the last electron is found in the S, that means that this element is S block element. The same thing is applicable. I'm filling this with electron, and the last electron stopped at this S orbital, that means this is S block element. If I'm filling electron to these orbitals, and the last electron stops or enter the 4s orbital and there's no electron again, that means that the element is S block element. So S block element is easy to spot. They are normally the group 1 and group 2 element. And how do you know them? When you are writing electronic configuration and you discover that the electronic configuration ends in S orbital, it means that that element is a S block element. So when the electronic configuration ends with a P orbital, the element becomes a P block element. When the electronic configuration ends with a D orbital, the element becomes a D block element. When it ends with a F orbital, the element becomes a F block element. That is how to know the block of element. For instance, if I have this and I'm asking now, which block does this element belong to? 1s, 2s, 2. Then I have 1s, 2s, 2p, 2, 2, 3. Then 1s, 2s, 2p, 3s, 3p, 4s, 3d. This 2, 2, 6, 2, 6, 2, 3. If you look at this, you discover that this element now, the electronic configuration ends with S. The last electron is found in S orbital. So this is S block element. If you look at this one now, where the last electron is found, where we stop writing the electronic configuration is in P. That means that this element is a P block element. If you look at this one now, where the last electron is found is in D orbital. That means that this one is a D block element. So whenever you finish writing electronic configuration, the last orbital then becomes the block of that element. So the next thing we talk about now is the group. How do we know the group of elements? So the next thing we talk about is the group of elements. So we have the S block element, we have the P block element, and the rest of them. So if you want to know the group of S block elements, it is the number of electrons in the last S orbital. We will see that during the examples. The group is just the number of electrons in the last S orbital. You will now know the group of S block elements. But if it is P block element, you are going to add summation. So the group of P block element is the sum of electrons in the last S orbital and the last P orbital. The sum of electron is the last s orbital and the last p orbital. You will get the group for the p block element. Then the way to know the period of element, every element, the way to know their period is the same procedure. The period of any element is just the number at the back of the last orbital. If you have written electronic configuration, maybe 1s, 2s, 2p, 3s, the period of this element will be 3 because the number at the back of the last orbital here is 3. Let's take, for instance, if I have this electronic configuration and I want to know the block of this element. The block of this element simply means where the last electron entered. The last electron did not stop at P. Where the last electron is found is in S. So this element is S block element. But had it been that the electronic configuration stopped like this, that means that the element will be a P block element. So, but this is what we are having. 3s1 is S block element. If I want to know the period of this element is just the number at the back of the last orbital. This is the first orbital S, but the last orbital here is a 3s. So this number 3 at the back of the last orbital becomes the word period. So if I clean this now, have this as my electronic configuration, this becomes a P block element because the electronic configuration stops at P. Then the number at the back of that last P becomes the period. So the period in this case is 2. If I have something like this, the electronic configuration ended with S, so this is the S block element, and the period becomes the number at the back of that last orbital there. So that is how to know the period of the element. Just a number, an integer at the back of the last orbital. So let's take example. The question now, a sample question is, write the electronic configuration of the following elements. 1 is hydrogen, 2 helium, 3 carbon, 4 neon, 5 sodium, 6 calcium. So to solve this question, I will say solution, bearing in mind that the S orbital maximum you can carry is 2, P maximum you can carry is 6, D maximum you can carry is 10, and F maximum you can carry is 14. And according to the alpha building principle, the way to arrange this orbital is 1s. After 1s, 2s. After 2s, 2p. Then 3s, 3p, 4s, and 3d. That is the arrangement of the orbitals according to the Medlong energy rule. So to solve the first one, which is hydrogen, the atomic number of hydrogen, Z for hydrogen is 1. So if I want to write the electronic configuration, I will start from 1x, that is going to be 1s1. So the electronic configuration of hydrogen is 1s1. It's just one electron. So you keep on giving electron until there is no more electron to give again. We only have one electron and we have given that electron to S. There is no electron again. So the electronic configuration is 1s. Then when we go to the next one, which is helium, atomic number of helium is 2. And the electronic configuration will be 1s2. The maximum number of electron S can carry is 2. But in terms of hydrogen, it does not carry up to 2. The reason is because hydrogen only have 1 electron. But here now, it have carried the maximum capacity, which is 2. And that is for the helium. Helium has only 2 electrons. It have carried the 2. So this is the electronic configuration of helium. Number 3 now. Number 3 is carbon. Carbon, the symbol is C, and the atomic number is 6. Then if you want to write the electronic configuration, that is 1s. After 1s, you go to 2s. So I will give 1s. Maximum S carries is 2. I will give it 2. Out of the 6, I'm still having 4 electrons remaining. And the next electron will go to 2s. 2s. And anytime you have S, the maximum they can carry is 2. So I will give it 2. The number I've used now is 4 out of 6, which means 2 electrons is still remaining. And I will now go to the next orbital, which is 2p, and give that remaining 2 electrons to it. So this is the electronic configuration of carbon. If you count the electron now, 2 plus 2 is 4 plus 2 is 6. That is this 6 you are seeing here. So this is the way to write the electronic configuration of carbon. Then when we come to neon number 4, the atomic number of neon is 10. Then if I want to write the electronic configuration, any element you are writing the electronic configuration, you first of all start with 1s. If you are done with 1s, you will now go to 2s, you now go to 2p until the electron has finished. Once the electron is no more, you will stop there. So now it will be 1s. The maximum s can carry is 2. Out of 10, I have used 2. 8 is still remaining. So I will go to the next orbital, which is 2s. And s carries maximum of 2. I will give you 2. Out of 10, I have used 4. 6 is still remaining. So I will now go to 2p. And the maximum that p carries is 6 electron. And the 6 electron is what is remaining. I will just give p the whole of the 6, because p can carry maximum of 6. So if you add this, 2 plus 2 is 4 plus 6, that is 10. So the electron has finished, and you will stop at this point, because this is the electronic configuration of the neon. Then the next one is sodium. Sodium number 5. Sodium, atomic number of sodium is 11. 11 is the atomic number. So we now have 1s2, then 2s2, 2p6. I've used 10 electrons, but I'm having 11 electrons. So there is a remnant of 1 electron. That 1 electron will go to 3s. So I will have 3s1. 3s1. So this is the electronic configuration of sodium. Now the next one, which is the last on the list here, is calcium. The electronic configuration of calcium, that is number 6. Calcium atomic number is 20. When we write the 1s orbital, the 1s orbital, the maximum number of electrons you can carry is 2. After 1s, that is 2s, 2. After 2s, we have 2p. The p, maximum p can carry is 6. After 2p, the next one you have is 3s. And s will carry maximum of 2. If you check 2 plus 2 plus 6 plus 2, we have 12 electrons out of 20. So we still have more 8 electrons to make it that 12. So we continue writing. After 3s, the next one is 3p. And the maximum that p can carry is 6. If you count the electrons here, this is 4 plus 6, 10 plus 2, which is 12 plus 6, that is 18. But we are dealing with 20, so we still have more 2 electrons. That will now go to 4s. 4s, we carry that 2. So if you count this thing now, it is now 20. From here now to here is 10. Then this and this is also another 10, making it a total of 20 electrons. So that's how to write the electronic configuration. So the next thing we now look at is how do we know the group, and how do we know the period, and how do we know the block. So let's take a question on